Welcome to the second of a three-part webinar series on the shifts for the Connecticut Core Standards for Math. Before we get into this second shift of coherence, we need to take a look into the standards. The Connecticut Core Standards include both the content standards and the practice standards. The standards for mathematical content are very specific about concepts, procedures, and skills that are to be learned at each grade level. These standards are arranged into clusters or groups of related standards, and the clusters themselves are grouped into domains. The standards for mathematical practice do not change from kindergarten to high school. These standards describe behaviors such as reasoning, communication, making arguments, and modeling that demonstrate students are mathematically proficient. The standards for mathematical practice should not be taught in isolation, but rather embedded in every lesson. This is not to say that students should be engaging in all of the practices at all times in a math classroom. Rather, they should be used strategically in the design of the lessons and problems. Taking a closer look at the organization of the standards for mathematical practice, it can be seen that there are two overarching practices. The remaining 6 practice standards are grouped into the categories of reasoning and explaining, modeling and using tools, and seeing structure in generalizing. The standards for math practice and the standards for math content lead to the 3 instructional shifts required by the Connecticut Core Standards. These shifts of focus, coherence, and rigor help frame the way for changes in curriculum, instructional practice, and assessment to achieve alignment with the standards. The remaining part of this webinar will dive into the second shift of coherence. The coherence of the standards is based upon learning progressions. Learning progressions provide a framework for long-term development. They describe what it means to move towards more expert understanding in an area and consider how ideas build upon each other to form more complex practices or ideas. These progressions that provide a sequence of successfully more complex ways of thinking about how an idea develops over time is fundamental to the study of mathematics. Mathematics is not a list of isolated topics, but rather an interconnected body of knowledge. The Connecticut Core Standards for Math developed out of progressions documents. Before any standards were developed, the progression of a topic over time was established. Once it was understood what the progression looked like, the standards were identified and a grade level attached to them. Through this process, the standards develop mathematics by making connections. Students are able to use these connections to build upon previous learning. Learning that is built upon progression does not only benefit students, but educators as well. By understanding the intended outcome of learning over time, educators can determine how best to scaffold instruction, use assessment data more purposefully, analyze student work to drive changes in practice, and support struggling learners by understanding what is needed to support their learning. The learning progressions that are the foundation of the standards leads to the second shift of coherence. Coherence enables the mathematics to make sense to students because it links learning within and across grades and builds upon the previous understanding to build the new learning. This diagram uses the domains at each grade level to demonstrate the learning progression of the mathematics standards. There are some domains that span many grades. Furthermore, in the elementary grades, the majority of the work focuses around building number sets. This is done purposely so that as students advance to middle school, they can begin to apply that understanding to more complex concepts. In the first webinar of this series, major work of the grade was discussed. This slide shows how students progress towards algebra by focusing on the major work of each grade. The K-8 progression is very well designed to create a cohesive learning experience for all students that prepares them for success in high school math courses. Each grade level holds a critical role in the development of the requisite knowledge. In this way, focus and coherence are closely linked. Similar to the shift of focus, there are two types of coherence evidenced in the standards. One is coherence within a grade. This coherence can be within the same domain or across domains. The other type of coherence is across the grades. Examples of both types of coherence will be explored as we continue this webinar. The connections in the standards are explicit. Through the use of the coherent connections in the standards, supporting standards are in service to the major work of the grade. In this grade 1 example, measurement in data is not considered major work of the grade, but instead of bar charts being yet another thing to cover, the standard is telling you how to aim bar charts back around to the major work of the grade. While in the past, picture or bar graphs might have been distinct things to be assessed, now they connect to the major work of the grade, making for a more coherent learning progression. This concept of coherence within a grade spans all grade levels. In this grade 8 example, the supporting work of statistics is linked to the major work of linear algebra and functions. This is coherence within the grade level between one domain to a specific focus cluster or topic. You may be wondering what this coherence looks like in practice. The coherence should be evidenced through the problems and tasks that are part of the instruction. In this example, it is evident how this problem relates measurement to the major work of grade 4, specifically multiplicative comparisons. These types of problems that highlight the coherence within the grade level standards serve to make the math more meaningful to the students. Often what is easily identifiable at the K-8 level is not discussed at the high school level. However, the shifts of focus, coherence, and rigor are needed at every level. At the high school level, the progressions can be identified within the conceptual categories. As seen in this example with the conceptual category of algebra, one standard speaks to solving a system of linear equations. In the same conceptual category, another standard requires students to solve systems that involve both a linear equation and a quadratic equation. The resources that are used to support the instruction must have evidence of the progression of a topic. This is not to say that materials should not have any content that is off grade level, but it is important that this content does not interfere with the grade level content. Many resources contain reviews of previous content. Ensuring that this is indicated as review is crucial so that teachers understand it is not grade level content. Similarly, resources often attempt to push students to the next level. Provided this does not cause students to become confused with the current learning, this can be acceptable. An example of this can be seen by viewing this portion of a table of contents from a grade 4 math resource. The first lesson is about arrays and area models. As you may be aware, this is grade 3 content. However, beginning a unit with a brief review helps build the connections in the learning. Further in this unit, the 9th lesson mentions the shortcut method. The shortcut, or standard algorithm, is not taught until grade 5. In this case, the standard algorithm is being used as a strategy based on place value and therefore is not off grade level content. While the previous example shows how the materials align with the progressions of the standards, there are instances when there is in fact off grade level content. This slide shows two examples of this. On the left, the students are being asked to write equivalent expressions by combining like terms, which is grade 6 work. In this case, including these problems does not assist in deepening the understanding of the grade level work. On the other hand, the second example on the right allows students to develop a deeper understanding of equivalent fractions by working with other denominators that are not specifically mentioned in the standards. As previously mentioned, there are two types of coherence, within and across grades. We have examined coherence within a grade and within the materials of a specific grade. Now we will explore coherence across the grades. This slide shows the progression of adding and subtracting from kindergarten through grade 2. It is evident how the learning builds upon the learning of the previous grade and that the mathematics gets more complex year to year. To further demonstrate this point, this video explains the progression of fractions.
This unit explains the common core approach to adding and subtracting fractions, building on the idea of unit fractions. In kindergarten and first grade, students usually represent numbers with set models, that is, sets of objects. They represent addition by putting these sets of objects together. In second grade, students relate addition and subtraction to length. This includes representing sums on a number line. The first addend of the sum is represented as a length from 0. The second addend of the sum is represented as a length from the point corresponding to the first addend. The point on the number line found by placing the two segments of length 4 and 3 end to end represents the sum of the addend. In third grade, students represent fractions on number line. And in fourth grade, they understand a fraction like 5/3 as the sum of unit fractions. Using this method of building fractions from unit fractions, students can add and subtract fractions with the same denominator. For example, 1/3 plus 4/3 can be represented by finding the point that is 1/3 plus 4/3 units from 0. Mixed numbers can be written as equivalent fractions with the same denominator. For example, 7 and 1/5 is just shorthand for the sum 7 plus 1/5. 7 is equivalent to 35/5, and then 35/5 plus 1/5 is 36/5. In grade 4, students add fractions with different denominators, where one denominator is a divisor of the other, so only one fraction needs to be changed to write them with common denominators. For example, to compute 1/2 plus 3/4, since students can write 1/2 as 2/4, they can then add 2/4 plus 3/4 to get 5/4. In 5th grade, students are asked to add and subtract any fractions with different denominators. For this example, students can subdivide each 4th into 3 pieces and each 1/3 into 4 pieces. The resulting fractions are both written in 12ths. Through repeated examples, students in 5th grade can generalize that fractions can be added by subdividing the unit fractions in one using the denominator of the other. The process of finding the least common denominator should not be the focus of fraction addition, but rather the focus should be the understanding behind what fraction addition means. It is not necessary to use the least common denominator to find the sums of fractions. Any common denominator will work.
As highlighted in the video, the understanding of fractions builds upon the previous understanding of whole numbers. Using previously learned concepts to understand new concepts makes the math make sense to students. This is evidenced in the standards on fractions from grade 3 to grade 5, in which students begin by comparing fractions with the same denominator, moving on to comparing with different denominators, which leads to adding and subtracting with unlike denominators. This is also evident in looking at the progression of multiplying and dividing fractions. You see that over these 3 years, the students are building on previous knowledge and not just repeating the same thing each year. You see that in grade 4, students apply and extend previous understandings of multiplication to multiply a fraction by a whole number. In grade 5, that knowledge and skill is extended to multiply a fraction or whole number by a fraction. Also in grade 5, students extend previous understandings of division to divide unit fractions by whole numbers and the reverse. In grade 6, students will continue to build on the foundations laid and will divide fractions by fractions. These are clear and carefully laid progressions. These last few slides have used fractions as a way to demonstrate coherence across the grades. Fractions is a focus in grades 3 through 5. However, standards in K through 2 build foundational knowledge that is a prerequisite to understanding fractions. And standards in grades 6 to 8 are based upon the understanding built in grades 3 through 5. In order to see how the tasks throughout the grades connect, please pause this webinar and locate Coherence Activity 1 and identify which grade level each task belongs. When you have completed the activity, you can check yourself with the key. This idea of coherence among the grades is not exclusive to the elementary level. This slide shows the progression of solving equations in the middle school. Furthermore, at the high school level, the progressions are not exclusive within a single conceptual category. This slide shows how an algebra standard links to a geometry standard and how the two come together to provide the foundational learning in order to understand a standard in functions. So what does this look like in practice? If teachers have made the shift to coherence, it will be evident in a variety of ways. A teacher may launch a lesson that anchors the new concept to be learned. Students will make comments that demonstrate that they see connections, and students will be able to explain those connections. To assist teachers in making the shift to coherence, Jason Zimba, a lead author of the standards, created a wiring diagram. This diagram has been converted into digital format by Student Achievement Partners. In this tool, each of the standards is illustrated with tasks, lessons, and assessments, as well as excerpts from the progression documents. The Coherence Map and supporting resources can be used to build student understanding by linking together concepts within and across grades, identify gaps in a student's knowledge by tracing a standard back through its logical prerequisites, and visualize and understand how supporting standards relate to the major work of the grade. The best way to get familiar with the interactive Coherence Map is to use it. Please pause this webinar and locate Coherence Activity 2. This is a scavenger hunt that will guide you through the map. Once you have explored the map, a key to the scavenger hunt has been provided. To summarize the learning of this webinar, Coherence links the major work of each grade level, provides a natural progression of content, and supports mathematical connections. The standards are built with a coherent structure. However, coherence still needs explicit attention in teacher lesson planning and unit development. As previously mentioned, the standards originated out of progression documents. These documents go into great detail about the progressions for each domain and conceptual category. These are rather lengthy, so to look at the progression of the standards by grade band in an easier-to-use format, please visit the Connecticut Core Standards website. Thank you for viewing the second of the three-part webinar series on the shifts for the Connecticut Core Standards for Math dedicated to coherence. The third part will be dedicated to exploring the shift of rigor. If you have any remaining questions, please feel free to contact me. Have a good day.